Hi, everybody. How are we? Good. It's good to be back at NDC Oslo again. It's my favorite conference in the world, to be honest. My name's Scott Allen, and I came to talk to you today about resilient applications in Azure. So if you want to build resilient services, resilient applications, what I want to do is show you some of the Azure-specific features that you can take advantage of, as well as some general principles and practices that you could apply with any cloud provider. And what we're really talking about is, I want to build an application or a service that is going to be highly available. There's no perfect availability in the cloud. Something has to go down at some point. So we just need to figure out how highly available do we want our application to be. Yes, I would like my personal blog to be up all the time, but I'm not willing to spend the money to make sure that it's up 99.999% of the time. It gets very expensive, and we'll talk about that. And that's why the amount of resiliency that you build into an application or into a service, yes, there's going to be some technology choices that you have to make, but there's also some business choices that you have to make. How much are you willing to spend to give yourself a highly available application? Not spend just in Azure resources because you're allocating redundant storage or redundant virtual machines, but also there's going to be a price to pay in your application and your code base and the complexity in the code that you write, because as we'll see, instead of writing a simple controller for a web API that just depends on a database, if you truly want to be resilient, your code will be prepared for those times when that database is not available. So maybe you have to fall back to a Redis cache or some other information source. And that just complicates the code, complicates debugging, and costs more. And it turns out that if you're a lot of the patterns and things that we'll look at will make your application not only highly available, but also allow it to recover from a disaster. Maybe a natural disaster that takes out an entire data center. That would be really bad. Or just a disaster that takes out a hard drive on one virtual machine. So what do you want to recover from? If you're worried about the natural disaster that takes off an entire data center, that's a lot more expensive to make sure that you can handle that situation than just recovering from a failed hard drive. So those are the kind of topics that we'll talk about. And the first thing that you need to understand when you're doing any of this work is it's important to understand the cloud platform that you're using, whether it's AWS or Azure or Google, and understanding the different resources that are inside of that platform, not only how you can use them, but Azure has this huge surface area now. Virtual machines, storage, networking, app services, developer services, things like HD Insight and machine learning. You have to look at each of these individually. If you're using these in an application or service, you have to look at them and first of all ask, how can this fail? What do I do if it does fail? Because many of these resources do have some sort of contingency plan if they go offline. And it's also important to understand the availability numbers for each of these resources and under which conditions those availability guarantees apply. So for everything that was listed on that previous slide, you can do a search for Azure Service Level Agreements, and you will come to a web page that looks like this that lists everything that you can get to in Azure, every resource that you can create. And so if you're using, let's say, a virtual machine and an Azure SQL database, if you're really planning for high availability, it's important to go into this page and look at the service level agreement and, let's say, click on virtual machines. And in the opening paragraph of that service level agreement, Microsoft will give you two pieces of information. Under, first of all, what is the guaranteed uptime, like 99.9% or 99.95%, and also the conditions under which they will guarantee that uptime. So if you go out and you provision a single virtual machine in Azure, there is no SLA or guaranteed uptime. If you go out and you provision a free or a basic app service to host a website, again, there's no SLA there. So you have to understand under what conditions there's an SLA. For an app service, I would have to go to at least the paid basic tier to get a 99.95% SLA. And then once you understand all the resources that your application is using and what the guaranteed uptime numbers are, you sometimes just have to work through things like, okay, if I'm using one resource that is 99.9% available, and by the way, if Microsoft doesn't meet that number within a month, they'll also state in the SLA what you can get for that, and it's typically just a credit on your subscription. But if I'm using one resource that has 99.9% guaranteed uptime, that's 43 minutes of downtime a month. But let's say that's a resource that depends on another resource, some database service or something like that, that's 99.95% available. That's another possible 20 minutes of downtime that, of course, those two don't overlap. So my application, my service, could have 60 minutes of downtime in a month, and Microsoft wouldn't have to provide me any credits. They have met their guaranteed uptime numbers. And those are the kind of situations that you have to study and say, is that enough for my application? Do I have a service level agreement with my customers or my business partners or the people that are coming to my website? And if I'm down for 60 minutes a month, will that impact my business or hurt my business? And if not, that's when you have to start taking some approaches and some strategies that we'll cover in this talk about improving those numbers. So again, going back to the topic of every resource in Azure has some redundancy or some contingency plan built in for when something does fail. So for example, it's important to understand that if you're using blob storage, it's very easy to configure redundant storage in the portal. So for example, if I go to any storage account in the Azure portal, is that visible in the back? Okay, thank you. Hard to see up there. And go to the configuration for that storage account. Every storage account offers me some different types of replication that I can use to make sure that when disaster strikes, I'll still have my data. So there's locally redundant storage. I don't believe that's the default. It was the default for the way I had something set up here, but locally redundant storage is every time you write a file into blob storage, Azure's going to make 3 copies of that blob inside the same data center. So even if an entire rack of servers catches on fire and they take it out of the building, there'll be 2 other copies of my data somewhere in that data center. And that might be fine for my business. But if I'm a little bit worried about an entire data center being offline, then I might go to geo-redundant storage, which would not only keep those 3 copies in the one data center, it would also make copies in another partner data center that's hundreds of kilometers away at least. And then the one that a lot of people go with is read access geo-redundant storage. And I'll talk about how you can take advantage of this in just a bit, but that's basically geo-redundant storage where my application writes a blob into blob storage. It's asynchronously replicated within the local data center to other nodes, so that I'm sure I have 3 copies of that data, but then it's also asynchronously replicated geographically to another data center where I can still access that blob and read it. So that's good. But of course, read access geo-redundant storage is going to cost just a little bit more than locally redundant storage. For virtual machines, if you need to set up a virtual machine in your application or for your service, it's important to put that inside of an availability set so that Azure can give you an SLA and say, we will guarantee that you should have 99.9% uptime. Basically, when you set up an availability set for a virtual machine in Azure, Azure lets you configure 2 important features of that availability set for when it comes to high availability. One is the fault domain. So you would put different virtual machines in different fault domains. The idea being that if I have 2 virtual machines, they're not in the same fault domain, then if something like a power supply on a rack of servers goes bad, it shouldn't impact both machines at the same time. Or if a network switch on the top of that rack goes bad, there should still be another one somewhere in that data center that is available and running. So that's fault domains, and then there's also update domains, which is if Azure has to reboot your virtual machine because it's updating the hypervisor, let's say, for all the machines on that physical server, Azure will guarantee that it's not going to take both your machines down if they're in 2 different update domains. That's easy to configure through the portal also. For Azure SQL, there's a couple things. You can set up replication for SQL Server in Azure with Azure SQL, so you can have a primary and up to, I think it's 3 or 4 secondaries right now. So when you commit a transaction into an Azure SQL database, that transaction will be asynchronously replicated to other SQL servers that are geographically distributed. And if the primary SQL server fails, Azure SQL can fail over to one of those secondaries. And there's also point-in-time restore with SQL Server, and that's sort of an interesting situation because replication and point-in-time restore are really two different things. Replication is a must-have, but my big fear is always that we'll release an application that has some logic bug that will update a table and set 1 million customers to inactive. And Azure SQL will happily replicate that erroneous data all around the world. And the only way to recover from that is not through the replicated data. The only way to recover from a catastrophe like that is to go to a backup and do a point-in-time restore. So with a lot of the Azure SQL plans, you can have, I believe it's 5 or 15-minute increments automatically, where you can just go back and say, hey, I want to roll back to 2:30 p.m. this afternoon before I deployed my application. And then there's app services. App services we'll talk about in more detail here, but with app services, it's easy to take an application or service and deploy it into Azure App Services and deploy it in a couple different data centers. It's very easy to deploy these things and manage those things, and that's one of the scenarios we'll drill into more detail here in just a bit. But let's start with just a simple scenario, and we'll keep building it up. Let's say you're not willing to spend a lot of money on high availability. All you want to do is implement a web application, deploy it into an Azure App Service, and that app service is going to use blob storage and Azure SQL. We're not going to worry about replicating SQL Server. We might set up blob storage to be geo-replicated just so that we make sure that we save any files that get placed in there. There's still a few things we can do in this situation that aren't too expensive that will give us better availability numbers. One is every app service that you create in Azure is associated with an app service plan. And it's the app service plan that describes the type of hardware your web application is going to run on. So do you want a 2-core machine or a 4-core machine? Do you want 3 gigs of memory or 7 gigs of memory? And that app service plan, you can also describe how many instances that you want of that particular server. So it's really easy to go into an app service plan and say, I want 2 instances, and Azure will automatically have a load balancer in front of those 2 app service servers, so that if one goes down, there's still another one that's always running. So that's nice for scalability, but also for high availability, or higher availability. And another thing you could do that's very easy is set up connection resiliency. So the idea, if your app service tries to connect to a SQL database, and it initially gets rejected, and that could happen for any number of reasons. There could be something going on at the network at that time. The network could be saturated. You also could be connecting to a database where you haven't provisioned enough power in Azure SQL, enough DTUs, and that server is basically just saying, no, we're not going to accept this request right now, we're overloaded. If you could keep retrying that connection to get to the database and issue a query, that would give you a little better resiliency in your application. And fortunately, a lot of the SDKs that Microsoft provides for various Azure features and resources have retry logic built in. All you have to do is just use the SDK. So for example, Azure Storage. Yes, behind the scenes, everything in Azure is HTTP. So if I want to upload a blob into Azure Storage, all I need to really do is an HTTP post operation, and I can put something in Azure Storage. But if I'm just doing low-level HTTP put and post and things like that, I would have to build my own retry logic. If I just use the Azure Storage SDK wrapper, and there's one for C# code, and there's one for JavaScript and Ruby and all the popular languages, that'll already have some retry logic built in. In fact, this little bit of code here would show you that when I create a blob client with some sort of connection string that would grant access to a storage account, I can set up some blob request options to say, first of all, location mode. My location mode is primary, then secondary. So if I have that read access geo-redundant storage set up for my storage account, what the SDK will do for me automatically is try to go to my primary storage account location. Let's say it's in eastern United States. And if for some reason it cannot reach the blob storage there, it'll automatically fall back to a secondary, which I might have configured for central US or West Europe or somewhere else in the world. And that'll just happen for me. And then there's different sorts of retry policies. The default is an exponential retry, where I think it'll retry 3 times and it'll just keep increasing the timeout after each retry. But there's other retry strategies that are in the SDK, And you can write your own retry strategy. You just have to implement a specific interface and plug it into the SDK. For the entity, so Azure SQL is one exception. There's no SDK for Azure SQL. It's just using ADO.NET. But in the entity framework, both the entity framework before .NET Core and entity framework core, there are some resiliency features built in. Essentially, with entity framework core, this would be a snippet of code from an ASP.NET Core application or a .NET Core application. There's an extension method for SQL options where I can say enable retry on failure. And the entity framework is smart enough to look at the error codes that are coming back from Azure SQL to say, oh, that's the type of error that I could retry. It's not the type of error that's a hard permanent failure or a logic error. It's something that I could retry. So those things are built in. Same thing for DocumentDB, same thing for Azure Redis Cache. So a lot of these SDKs have that logic built in. You just have to sometimes just turn it on and take advantage of it. And that's good. Otherwise, what do we do? So let's say we're trying to get to SQL Server, and SQL Server really is down. So I am not, even with all my retries, I'm not making it to SQL Server or to DocumentDB. That's when things start to get a little more complicated and a little more costly, not only because you have to purchase more resources, but also the way you implement your code. So the database isn't available. What do I do? Well, if I'm just trying to do a read operation, maybe I could set up an Azure Redis cache in Azure, and I'm aggressively caching information that I read out of the database. So now when the database is down, I'll have the proper abstractions in place in my code to go to maybe I'm going to the cache first in any case. And if the cache is down, I go to the database. But you could work it in either direction. And for write operations, okay, the database isn't available, so maybe I'll drop something in a storage queue or an Azure Service Bus queue. And one thing that you might notice here is that I have read operations that go in one direction and write operations that go in another direction. So if you're familiar at all with the CQRS, with command query responsibility segregation, that is a fantastic pattern to use in applications and programs that you want to be resilient and scalable. CQRS is something to look at. Well, let's drill into this in a little more detail. Okay, so now I don't have a simple just app service anymore. I'm going to deploy my web application or API to an app service in Azure, which is really easy to do from Visual Studio. And that app service is going to always talk to a queue when it needs to, instead of talking directly to the database, I'm just going to drop messages in a queue that will ultimately update the database, but those messages will go through Azure Web Jobs that can just asynchronously sit and run and listen for messages in a queue, or Azure Functions if you prefer to do the same thing in a serverless way. And that would all be my storage account. I could also set up a CDN in Azure. Yes, yes, yes. We'll talk to DocumentDB. We'll talk to Azure SQL. Basic architectural diagram here, but the piece I really want to call out here, is the queuing. So to me, building a resilient application is going to require queuing if you're really serious about it, some sort of message queues. Because message queues can do a couple things. Not only, hopefully, will a message queue be available, even if a database is not in a good state, but a message queue can also help you do things like load leveling. So part of the trick to high availability is not just avoiding disasters, it's also avoiding the crushing weight of too many users coming to the site at once and overwhelming a portion of my application, either the web server or some of the back-end processing. And by introducing a queue, what I can do is take all these requests from users to purchase orders or purchase plane tickets or whatever they're trying to do and drop them into queued messages and slowly process through them, or process through them as fast as I can, but not overload some of the back-end systems that are now trying to make too many connections because there's too many users on the site. And for those of you that haven't used Service Bus, I just wanted to show you a small code example and show you in the portal just how easy that is to set up. I do have a service queue already configured, Service Bus queue, which is, here we go. When you go in to create a new resource in Azure, you would ask for service bus queue, and you fill in some basic configuration information like the name of the queue that you want. So this one's called, or the namespace for this is PS-messaging. And it has one queue inside right now called orders. So there's queues and there's topics in Service Bus. Queues are really about, I have a message, I'm going to put it in a queue, and there's one person listening to that queue to pull it out and process it. Where topics are more like a pub-sub mechanism where I can say, I have a message to put into this queue, this topic, and it's really the same API. But there can be multiple listeners on that topic to pull out messages and perform different actions. So maybe one component is listening to a topic to send off email notifications, and another component is listening to that same topic to update the database. And the code to use this orders queue is extremely simple. How do I send a message to a service bus queue? It's literally just 3 lines of code. So this is a very crude program, but basically create a queue client from a connection string. A connection string would look something like this. So my endpoint is ps-messaging.servicebus.windows.net, and then there will be an access key or a secret token in that connection string. Give me a queue client, create a new brokered message. What I can do is do JSON, put a string in there, put JSON object, put XML in there, whatever I want, into a brokered message, and then just send that to the queue. So it's really about 4 lines of code there. And to read something from that queue, one way to do it, just set up an Azure function or an Azure web job or a service on a virtual machine that sits in a loop, and not even a loop, just listens for a message, client.onMessage. So for every message that arrives in that same queue, we'll pull that out, get the body. From there, we could deserialize it using Newtonsoft or something. This program is just printing out the body that it assumes to be a string and printing out a message ID. So hopefully this is giving you some ideas about resiliency, but let's go one step further. So let's say I have that set up. I have queuing in place. I'm using an Azure Redis cache. I'm using Azure SQL and it's geo-replicated. But now I have an application that I am willing to spare no expense to make sure it is available all the time, as highly available as I can make it. And I'm even worried about an entire data center going offline or an entire data center going away. That's where I could take that environment, app service, queue, database, and replicate it through a couple different data centers inside of Azure, and then use a load balancer called Traffic Manager to send my customers to one of those 2 regions, or one of 3, or one of 4. Let me talk about Traffic Manager for a second. Load balancing is actually important not just for scaling up and balancing a load across multiple resources. Load balancing is also important for high availability, because one of the things a load balancer can do in Azure is detect that, oh, that particular machine's down now, so let me send all the traffic over here to a machine that's currently up. And there's 3 different load balancers in Azure, although there's only one that has the name load balancer. So if you go into the Azure portal and create a new resource and say, I want to create a new Azure load balancer, what you're getting is a layer 4 load balancer. So that's a load balancer that works at the TCP/IP level. It'll accept incoming TCP/IP connections, and then you will configure endpoints behind that load balancer and tell it forward it to one of these places, one of these virtual machines, and it'll forward things along. So that'll work for anything that works over TCP or UDP. So you could be doing HTTP traffic, or you could be doing WebSockets. There's also what's known as the Azure Application Gateway. That's a layer 7 load balancer. So this load balancer works at the application protocol level, and it understands natively protocols like HTTP and HTTPS and WebSockets. So one of the neat things about the Azure Application Gateway is because it understands HTTP, you can have it implement things like sticky sessions. It's basically a reverse proxy. So you could sit it in front of a web application and tell it that when a client makes a request, it should set a cookie so that all the subsequent requests from that user go to the same machine, because For some reason, we want to keep the user on the same machine, probably because we're using in-memory session, which is turns out is actually not a good idea for high availability. But it's possible with that particular load balancer. And then there's Traffic Manager, the one that I'll show you a little demo of here. Traffic Manager works at the DNS level. So if I'm using it in front of a web application, the way it's being used is my web application, when I type in scottallen.com, my web browser goes off and says, oh, dear network, what is the IP address for scottallen.com? And it's ultimately Azure Traffic Manager that would answer that question and say, oh, here's the IP address. And it'll answer based on some rules that I program into it. Let's take a look at that real quick. So I have a couple copies of the music store that are out there. I have the ASP.NET Core Music Store. One of those is deployed in a data center in the East US, so ps-musicstore-East US is the URL for that. And if I look at the bottom of the browser here, I have the layout page read an environment variable that actually tells you what data center you're in or what Azure region you're in. So it clearly says East US. And I have another version of that running in West EU. Just make sure that is up and running. So ps-musicstore-westeu.azurewebsites.net. But of course, I don't want my customers to necessarily know there's a West Europe version and an East Europe version. What I'd like them to do is just go to some custom domain or something like ps-musicstore.trafficmanager.net. See if I typed that correctly. And that particular request actually went to Azure Traffic Manager. I'll show you the configuration here in just a second. But Azure Traffic Manager, in this case, returned the IP address of actually the West Europe deployment, because that's the way I have Traffic Manager configured. It's going to send me to the data center that has the least latency. So the URL there, ps-musicstore.trafficmanager.net. How would I set that up? Well, inside the portal, I would go to, let's come over here to all resources for a second. Well, first of all, I would come in and I would say, dear Azure, I want to add a new traffic manager. So if you haven't been in the Azure portal lately, you would come in and click the plus button, and you would say that you want to set up a traffic manager profile. That's what I already have set up. Let me just show you the configuration for it. There's really just two key blades of important information. So here's the traffic manager profile. So first of all is the configuration itself. In this configuration, I can first of all set the routing method for Traffic Manager. Performance is a way of telling Traffic Manager, send the request to the data center that has the least amount of latency. So if I'm over here in Europe, chances are I'm going to go to the West EU. If I'm in the United States, chances are I'm going to go to the East US. There's also geographic. So that would be a way to say that I want all EU customers to stay in and to go to an EU data center that I have configured, and all US customers to go to a US data center. So it would disregard latency. It would just strictly route requests based on where they're geographically located. There's also priority. So first of all, performance is a good way to say, I just want to give my customers the best experience. So I have all these things set up and running. I've spared no expense. I have app services and instances running everywhere. Just send them wherever it has the least latency, wherever makes them happy. I could also do priority, which would be a way of saying, okay, I have one data center. This is one thing you could do with it. I have one data center where everything is set up and highly tuned, and I have everything scaled out, and that's the #1 priority. But in case that goes down, here's a #2 priority that I have set up in another data center somewhere, and you can start directing traffic over there if you've detected that the first priority wasn't good or is in bad shape. And then there's weighted, the weighted routing method. And that's actually an interesting one, because I could say, for example, send 90% of my traffic to East US and send 10% of my traffic to West EU. And it could be any two deployments. But that one can be interesting because you can set up one of those situations where you have a new release, you want to put it out in the public, and you want to see how it behaves, you want to see what angry customers actually do to this thing. But you don't want everyone to see it, because if it has a bug or something, it could cause bad press. So Let's push that out, and we'll have Traffic Manager set up to just send, let's say, 5% of our traffic to that new deployment over here. And we'll evaluate it and monitor it and make sure it's actually going to work out in the wild. So once you've chosen the routing method, based on what you want to do, you can also set the DNS time to live. So remember, this is a load balancer that works by responding to DNS queries. What is the IP address for this domain? It'll hand something back to the client. You might want to make that shorter, if you're doing failover testing and things like that. But the default is 5 minutes, so if something falls over, one of your customers will have to wait at least 5 minutes before getting a new IP address and going to a new data center. And then there's also monitor settings in Traffic Manager. This is how Traffic Manager determines if a service is operating normally or if there's trouble. So basically, I'll show you how we plug in endpoints into Traffic Manager, which is a way of saying, here's the different places to route traffic. And what Traffic Manager will do is go to each of those endpoints and make a request on this port using this protocol and at this URL, so I could change that to something else. And if that request does not return an HTTP status 200 code, Traffic Manager assumes that there's some sort of problem there. And if it does that, I believe 3 times, then Traffic Manager says, okay, no more traffic over there, there's obviously a problem. And it has to be a 200 response, not a 302 response or anything else. It has to be a 200 response. So in this case, I just set up to hit the root of the website, make that request, see if you get a 200 back. But you can do interesting things here too. So for example, if I had a specific URL for the Traffic Manager probe, then the logic behind that URL inside of a controller or somewhere could actually do some system checks and say, we're having trouble with SQL Server. Maybe we should return a 500 error here for the check and get some of the Traffic Manager traffic away from us, that sort of thing. So once you have that configured, then there's endpoints. So yes, discard some edits. This is basically where I go in and I tell Traffic Manager, hey, I have this new endpoint. It is, sorry for the scrolling, it's an Azure endpoint or an external endpoint. So you could use Traffic Manager to route to stuff in your own data center if you wanted to. It doesn't have to be inside of Azure. An Azure endpoint or a nested endpoint. Nested, you can also set up nested Traffic Manager profiles, which are interesting. So maybe the top level profile weights based on geography, and then once you route to the next Traffic Manager, it looks at the request and does some calculations based on priority or weight or something like that. For my app services, I would say, hey, I have an Azure endpoint. Give it some name. The target resource type could be an app service or an app service slot or a public IP address that I've assigned to one of my virtual machines. And then, since I chose app service here, the portal would give me a list of app services to choose from. And it's really just that easy. So now Traffic Manager is running, and it's probing those 2 different endpoints and routing traffic there as appropriate. Load throttling. So another aspect of high availability is what happens when I have customers who are calling a service, and some of these customers I might not trust. They might be doing something odd. They might have a bug in one of their backend services that's calling my service, and it's running in a loop, and it's issuing 1 million calls a second, and it's overwhelming my backend service. What could you do in a situation like that? There is a technology in Azure called API Manager that you can set up that will implement a number of features, but one of those features would be to throttle calls on from a specific client or on a specific subscription or who's using a specific access key so that they don't overwhelm things in your system. And I'll just show you API Manager real quickly. Let's go back to all resources. And I'm looking for, oh, it was at the top. This API management service. So here's the way this works. Someone could spend a couple hours or an afternoon describing, everything you do with the API management service. But the basic idea is that I have a set of services that I need to manage and that I need other people to be able to access and sign up for, and I need to do this in an orderly fashion. So I can use this API management service in Azure to wrap all of my services across disparate things. I could implement them in functions and put them in virtual machines and just have a collection of services everywhere, but provide a cohesive single endpoint for my customers and business partners to use, which would be psmusicstore.azure-api.net. And I can provide them a developer portal, and I can provide myself and other users in my company a publisher portal, which will allow me to manage these APIs. So the developer portal that Azure gives you, API management, is one of those typical experiences that you would have as a developer when you want to go out and use Google Maps or Bing APIs or any of those things. You know, you have to sign up somewhere, you have to get a subscription key, and then you have to plug that key into your application. Azure API Management will basically give you that developer portal where you can hand out this URL to other developers, and they come here and they can sign up and they can manage their keys and they can start working with your API. And this is also where you can provide documentation for all of your APIs. There's a place where developers can open issues against your APIs and so forth. And then there's the other side of the house, which is I'm the person writing the API, and I need the ability to see what APIs I have published. So here's my Music Store API. I need the ability to import a new API that someone just wrote. So I can go in and I can say, hey, I have this API endpoint over in this other application. It exposes Swagger documentation. So I'm just going to plug in the URL. And this API gateway will read the Swagger documentation, figure out all the operations that are inside, and just produce some nice documentation pages and so forth. But one of the important things that you can do with API Manager here is, let's cancel this, policies. When it comes to things like making sure you're highly available and making sure that people aren't abusing your application in some way, things like policies can help, because not only can you require authentication, require authorization, require specific headers, you can also go in and say, you know what, I have this Music Store API, people have not been treating it very nicely, they've been making too many calls against it, so I'm going to limit the rate call per subscription on this. So add a policy. Let's use limit rate call per key. And I realize that's probably really small, but there's some XML. Everyone loves XML. Some XML you can put in a file that says things like, I want to limit the number of calls. We're going to count the number of seconds where people are making calls. And we're going to make sure that they limit their calls to, well, I forget what where the actual number is stored in there. But you could do that. You could throttle things. Let's talk about Service Fabric. Anyone using Service Fabric? Just curious. Hear of Service Fabric? Yeah. So Service Fabric is interesting. Service Fabric, there's two perspectives to look at with Service Fabric. First of all, I want to tell you that Service Fabric is one of those technologies that Microsoft itself uses to implement things in Azure. So if you look at DocumentDB or Cosmos DB or whatever they call it this week, and you look at Azure SQL Database, those are implemented using Service Fabric. And there's two perspectives. The first perspective is the runtime. Service Fabric is a runtime environment that allows you to manage services in a way that will make them available and resilient and reliable. And that runtime isn't tied to Azure in any fashion. So there's a Service Fabric SDK that I can install on any machine, and there's a runtime that I can get installed on any machine. So I can have a Service Fabric cluster in Azure or in Amazon or in Google, or I could take the 6 laptops that I have laying around in my basement and make a Service Fabric cluster out of them. The other perspective of Service Fabric that I'll show you also briefly is the programming model for Service Fabric. So there's also an SDK and an API that you can use from Java and C# to create Service Fabric reliable services that Service Fabric will manage. So here's the idea. Let's say I have the traditional monolithic application the movie store application, it's a website, it's a web service, it's all these things. If I were to really want high availability and I'm looking at Service Fabric as a way to give me that high availability and disaster recovery, what I would probably do, first of all, is break Movie Store down into, dare I say, something like microservices, but something where the components are a little more thinner and identifiable and that I can refactor out and separate from the rest of the system. So yes, there's still a web UI portion for the movie store, but I may take all the rules and things related to credit cards and put them into another component, let's call it payment. And I'll show you what it looks like to implement a reliable service in Service Fabric. And here's the deal with Service Fabric. Service Fabric is all about managing a cluster of machines. And then you tell Service Fabric about the application that you want to run and what services are part of that application. And Service Fabric will make sure that that application and the services are distributed around that cluster in an effective manner. And there's a couple different types of services that you can run. So for example, this A service appears on 4 different machines. Maybe that's the web UI portion of my application. Maybe I just want to install that on all the machines. It's pretty much stateless. Any state that it uses, it stores in SQL Server or some external persistent store. Service Fabric also has the concept though of a stateful service, which is very interesting for a lot of different applications. A stateful service, and again I'll show you the code here in just a second, is a service that Service Fabric knows you're storing state, and it's going to give you some reliable collections that you can use, like a dictionary and a queue that you can put stuff into, and it's transactional. So it looks like programming with an in-memory dictionary, but it's transactional and it's actually persisted and it's durable somewhere, and Service Fabric will make sure that that state is replicated around in this cluster so that even if one virtual machine is completely destroyed, that service will still be available and be able to run and it hasn't lost any data. Let's actually just dive into the code for this. So before I get to that, let's go over to this version of Visual Studio. Sorry, this version of Visual Studio. So when I create something for Service Fabric, I could do in Visual Studio 2017, I could say file new project, I want to do a cloud project, and I'm going to do a Service Fabric application. And what that would give me is a solution with 2 projects inside. The first project describes my application. That would be this project here. I'm building a movie store. But this has no executable code inside of it. It's really just metadata and parameters that I use to describe my application to Service Fabric, and then also to publish my application into Azure, which is relatively just simple to set up. And there will be XML files that say things like, this application, movie store, it consists of a couple different services, one called a counter service, which I'll show you here in just a moment, one which is the web service, which is the web UI for the application. And you'll notice things like instance count, which is basically a way where I can tell Service Fabric, I want to run this service and I want it to have 3 instances, or I want it to run on every node that is in the cluster, in which case I could set instance count to -1, and that just tells Service Fabric, run it everywhere. And I also have this service, this counter service. This is a stateful service, so it's actually using these reliable collections and storing stuff in a dictionary that has to be persisted. And one of the things I can do with a stateful service is provide a partition count. So partitioning is important for scalability. If I have so much data that it doesn't fit on a single node, I have to partition that data across multiple nodes. And we do the same thing with SQL Server, except there it's sharding, and MongoDB has sharding, and everyone either has sharding or partitioning, right, to break up data. So partition count is a way of saying, in this case, I have this range of numbers that I might use from -9 something to 9 something. If I wanted to, say, have 3 partitions to cover that range, Service Fabric would just take that range and divide it up into 3 categories. and now there would be one node in the cluster responsible for the lowest range, one for the middle range, one for the high range. A simpler example would be an address book. I have the range A to Z, and I could tell Service Fabric I want a partition count of 2. So Service Fabric might set up one partition that handles all the state for address book entries from A to M, and then a second partition, all the address book entries from M to Z, that sort of thing. Just here we're using numeric identifiers. That's the application project that describes the application and the services that are inside. And then there's the services themselves. So the easiest one to understand would be the web service, which is the web application. And this is an ASP.NET Core application that is set up to run in Service Fabric, so it looks a little bit different than an ASP.NET Core application that doesn't know anything about Service Fabric. And I do want to point out that Service Fabric has the concept of a guest executable, which means you could write a program in any language, Java, Ruby, whatever, Node.js, and you can have it managed by Service Fabric as a guest executable. And that program, that application doesn't have to know anything about Service Fabric. But if you're willing to take a dependency on Service Fabric, you can allow Service Fabric to more effectively manage your service. You can also take advantage of Service Fabric features. So this is an ASP.NET Core application. It's going to build a web UI, but it is plugged into Service Fabric. It has taken a dependency on Service Fabric. So typically when you go into an ASP.NET Core application and you look at the main startup method, you see things related to spinning up Kestrel and spinning up the web server and all that stuff. We're not doing any of that here. Now when we're launched by Service Fabric, and Service Fabric is telling us to start up. And one of the things we have to do when we're programming a Service Fabric is we have to register this service. So we're saying, I am the web type service, and I'm going to right now create a new instance of this service, and I'm going to pass in your context, service context that you provide to me to give me some more information about my environment, and we're off and running. So where's all the ASP.NET Core bits about Kestrel and configuration and all that stuff? It's actually tucked away in this class, web. So if we open up web, this is where you would see the code, specifically this code, which says, I want a new web host builder using a web listener or using Kestrel. I want to configure some services. I want to use this content root, the startup class, application insights, et cetera, And once I do .build, I now have a server process listening to port 80 or whatever port it's configured to listen to, and it will now take HTTP connections, right? Very exciting, yes. But this is now in a class that derives from Service Fabric's stateless service, which means when I execute this code, I'm executing that code to build my web server in response to Service Fabric telling me, hey, it's time to go out and create your service instance listeners. So if you need to listen for something over the network, you override this method, and that's where you create something. Not all services have to listen over the network. Some services might just listen for messages on a service bus queue or a storage queue, in which case they wouldn't have to implement this exact code right here. But let me just show you over in the Azure portal what happens when I right-click this thing and say that I want to publish it out there somewhere. We will go to maybe store cluster. Well, so first of all, I've written this web API, and everything else inside of this project is just regular ASP.NET Core. There's controllers, there's Razor views, there's layout views, all that stuff. jQuery scripts, whatever you want in your web UI. Now I'm ready to push it out into Azure. I want to run a Service Fabric cluster in Azure. And of course, with Azure, there's a way to click and say, I want to add a new Service Fabric cluster, and you fill out about 4 pages of configuration. It's not too terribly bad. And the Azure portal will just spit out a Service Fabric cluster for you, and that consists of a public IP address so people can reach your cluster from the outside, a load balancer that will accept, let's say, HTTP connections to that public IP address, and then distribute them across machines that are inside of the cluster. Maybe all of them, maybe just a subset of them. There's a resource representing the cluster itself. There's a virtual machine scale set. So this virtual machine scale set has, or should have, 5 nodes inside of it. If you haven't worked with a virtual machine scale set, it is a resource that you can create in Azure where if all you want is just 5 or 500 identical virtual machines in Azure, what you want is a virtual machine scale set. You want to create one of those and it'll just manage all those instances for you. And I can see I have 5 virtual machines running inside of this virtual machine scale set, and traffic will reach them because of the load balancer that was configured for me. Everything else is just storage accounts and virtual networks to keep those all on the same subnet. But let's look at the Service Fabric cluster itself here. And I'm going to open up this thing called the Service Fabric Explorer, where I've already deployed this application, by the way. And the Service Fabric Explorer, because I'm the admin on the subscription, it will allow me into this Explorer to see what is actually happening inside of the cluster any moment now. But I should be able to see that I have a Service Fabric cluster up and running. It has 5 nodes. It'll have this web service as part of the application, and we'll be able to actually see what nodes that is on. Okay, so the Service Fabric Explorer, I have 1 application deployed, that one that we have in Visual Studio. I have 5 nodes in the cluster. I could add more if I wanted to. 5 is the recommended minimum. Speaking of upgrade domains and fault domains, Azure has put each of those nodes into a unique fault domain. So there's a total of 5 different fault domains there, and also 5 different upgrade domains. So if something blows up or something needs upgraded, I should only ever lose 1 node. I have 1 application running inside, the movie store. This over here is telling me that I have 2 services inside of that application. One is the service that provides the web user interface. This is the instance of that service that is running. And if I keep expanding things, I'll basically see it's running on all 5 nodes. So it's running on every machine there. So even if 1 virtual machine goes down, someone should still be able to get to the web UI. Now that web UI depends on a counter service that is just a file new project thing that I put together with Service Fabric. All this does is, this counter service does is increment a counter. But it's interesting to look at the code because it kind of gives you an understanding of what Service Fabric can do. This is the world's quickest introduction to Service Fabric, by the way. This particular service is implemented in counter.cs. You can see this is a stateful service, not a stateless service. And it has a method, so here where we create service replica listeners, we'll create something known as a remoting listener. We don't want this service to listen over the public IP address. We don't want just anyone contacting the service. We just want other services inside the same cluster to be able to communicate with this service. And I'll show you how we do that in just a second. Essentially, we want other services to be able to call get count. It'll return the current value of the counter that the service is tracking. Where do we compute the counter? I'm going to skip down to the bottom for a second. Run async. This is another method that I can override when I'm using that Service Fabric API I'm deriving from stateful service. What I can basically do in here is set up a loop or start my listening to a message queue, whatever I need to do. What this particular method's going to do is say, let's go out to the state manager, which is part of the Service Fabric API, and please give me an iReliable dictionary with the name of my dictionary. So this is a reliable dictionary. Things that I put into it get persisted and they're stored. And I can actually back up that state and move it around if I need to. And then we're just going to set up an infinite loop. Or at least we're going to loop until someone raises a flag on a cancellation token. But we're going to create a transaction, because anytime I use those reliable collections, I need to have a transaction in place. Inside of the transaction, I'm trying to get to a value called counter. And down here, it's not the prettiest code. We're basically going to update that counter. The entry with the key of counter, we're going to update it with a new value. So we increment value, put it back in the dictionary, commit the transaction, and then go to sleep for a second. So this service is just constantly running in the background, just setting a counter, new value for the counter, just incrementing it one time after another. And eventually someone's going to want to come along and get the value of that counter. So how does someone call get count? I think this is interesting. So from the web application, if I wanted to call this method on this stateful service, what I would do is get a hold of a Fabric client, first of all. But first I need to describe what I want to get to. So I'm inside of an application that's trying to reach another service that's in the cluster. I don't go out and say, hey, give me the thing that's listening on this IP address in the cluster, or go to this node with a specific name. No, there's a URI scheme with Service Fabric where there's a layer of indirection. So I'm basically saying, I want to go into the Fabric, and in the movie store application, I want to find the service with the name of counter. And then Service Fabric will figure out how to connect me to that thing, so I don't have to know too many details. Since this is a stateful service, it can be partitioned. So when I connect to this service, I also have to indicate which partition do I want. So there's a little bit of code here that's saying, go out and give me all the partitions. Give me a list of all the partitions that are available for that particular service. I can do that through the Fabric client's query manager property. Then I can ask the service proxy to give me an instance of something that implements iCounter service. It should have this name, should have this URI, and using this partition key. And at that point, I basically have an object where I can invoke a method, it'll call the method in the other service, and I get the count value. But the important part of this all really is that Service Fabric is the one that if I go out there and let's say I look at a node, and let's see if we can find, actually let's do this. Let's open up counter. There I can see it's been partitioned 3 times. A stateful service will always have a primary and 2 secondaries. So the data will be replicated. And I can see that the primary for this partition is currently on primary 2. If I go out to this node, primary 2, and there's actually a programmatic way to do this too, if you just want to kill off nodes and see how Service Fabric reacts. I could click on the little context menu there and say, let's restart this thing. And we'll see how this behaves today, but I should eventually see that instance will be moved off of primary 2. Instead, one of these secondaries will become the new primary, and then there'll be a new primary placed somewhere else. I just might have to up the refresh rate here. But since I'm running out of time, you might just have to trust me. There you can see Service Fabric already kind of detected, oh, something's wrong there, a little question mark. And eventually it's going to have that counter service running somewhere else. So I can completely shut down a node. We'll never lose any of that state. We'll never lose the counter value or anything else that was stored in there. So Service Fabric is very appealing from the viewpoint of writing something that's reliable and highly scalable, because you can have a cluster with hundreds of nodes running with these services. And the last few things I want to point out are that to be highly available, you need to thoroughly automate everything. So you need to teach developers to never use the Azure portal to do anything. Always use Azure Resource Manager templates or scripts or provision things and update resources in Azure in a way that's repeatable. You need to do some load testing, because part of being highly available is making sure that you can handle load and that things don't fall apart, and you always discover things that you would never expect to fall apart, sometimes fall apart under load testing. Make sure you have monitoring in place. And I think that pretty much concludes this presentation. If you want a more slower, perhaps more guided tour of everything that I just went through, I do have 2 Pluralsight courses coming out in the next 4 to 6 weeks that cover all these topics. Instead of spending 10 minutes with Service Fabric, you can spend an hour with Service Fabric, and it'll be a little more watchable, perhaps. But I thank you so much for coming out today. I'll hang around for questions. Enjoy your conference.